Okay, thank you, Jeff. Thank you for welcome. Just to say that I am presenting this work on behalf of Natasha, who is one of our students. It's unfortunately she's unable to be here, so I'm presenting on her behalf. So, developing a framework to evaluate possible applications of NBS to improve air quality. So, this work is funded by Erasmus Mundus Joint Masters Program. So air pollution in cities, everyone has seen this, the famous Oak et al. 2017 book, the pollution dome, and how this reacts with the various processes in the city. So that is not the issue. So this isn't a problem. What we want to look at is this really. This is the work by Abhijit et al. So this looks at different types of vegetation and different types of street canyons. So the sort of red here, but it's kind of ochre color. There is a deterioration. So trees in very deep canyon is a deterioration to air quality. The green is an improvement. So hedges, green wall, green roof, etc. are allegedly good for street canyons of deep canyons as well as shallow canyons. And in shallow canyons, green roof, of course, has no effect. So this is the basis on which we are looking at different types of vegetation and different types of street canyons. So this is the workflow. What we are doing here, the main change here is that we are not using LCSAT process that WUDAP has put together. So it's not a unsupervised classification, it's a supervised classification. We are taking the six variables, the street canyons, type of vegetation, the amount of density, etc. We take Stewart and Oakes ranges, you write a Python code and try to sort of supervised classification. So that's the only difference here in the LCSAT mapping. Otherwise, it's very similar. So on the top left, you have the urban morphology, the aspect ratio, space availability to plant trees or various NBS. Orientation is a big issue. LCSAT map, etc. We know also from previous work that this work is done in Brindisi, southern Italy. The problem in Brindisi is the oxides of nitrogen. So we are only looking at nitrous oxides because there is no major issue of PM, etc. So we keep to that. We first do an LCSAT, a supervised classification using a Python code. It's on the reference finally. And then we have these different types of sources. Traffic is the main source, but in southern Italy, they also use a lot of, for want of a better word, very poor quality fuel to heat and cool heat also. I mean, to me, I'm from Scotland. To me, it seems strange to heat in Brindisi. They do heat. So and then industry, there's a cement industry, so that's also a major contributor to uh, air pollution. Then we put this in environment, of course, and come up with different types of green infrastructure, hedges, trees, etc. And also look at meteorological data from that. There are two stations inside this city, so we have data from that. So all of that feed into the results. So that's how the LCSAT map looks. This is as I said, this is not WUDAP, so it's slightly different. So the reason we selected this is because it's much more intuitive to planners in that city. They know the city better. So I don't know. I will have a chat with Ian at some point to see whether he agrees to this kind of supervised classification. And so we select these two areas, the boxes. So that's LCSAT 2. The city center is LCSAT 2, and on the north side of the lake is the Casale is LCSAT 5 and a bit of 6. It's very difficult to find a single site That's 300 meters by 300 meters, but that's only one LC set. Very little. So that's, at least here is kind of okay, but there is slightly different. Okay, so this is the results. So you have your street canyons and trees and hedges, sorry, green walls and hedges, etc. And this is the distance across the section of the street. And you have, apologies for the, almost you can't read this, but that's summer 5 p.m., summer 2 p.m., and winter, etc. Different seasons, different canyon geometry, and x-axis is the distance. So there's nothing here, and there is a variation, and there's nothing there because there's a building. So that's our result in terms of NV method Brindisi. LC set 2, this is just 2, because this is the city center, the highest built up cover there. So the case 1 is a green wall, case 2 is hedges and trees, and case 3 is evergreen. So here we have aspect ratio 1.2, that's the highest we can find in this city. Wind direction remains constant, roughly constant. As you know, Brindisi is on the east coast of the, it's at the heel of the boot, of the Italian boot, right at the bottom. So it's very close to the sea. So you have fairly constant wind direction southeast for winter and northeast for summer. Very heavy traffic. This is the hub to go to Albania and other places. So it's a major transportation hub. So it's a lot of vehicles. That's LC set 6 on the northern side of the city. And you see that summer and winter, different times, etc. Slightly different. So here we are only looking at evergreen and hedges and trees. So here the aspect ratio is very low, 0.4. Wind direction remains the same. And the traffic count is fairly low, almost half. So, what did we find? So, LC set using this kind of Python code and GIS is appropriate. It's probably slightly more relevant here than this unsupervised classification. So, we thought this is useful to come up with this kind of LC set. It's much more intuitive to people from that city because they know this city very well. So the Python code that we wrote is very useful for the planners in that place. So areas with high aspect ratio, the deepest canyon here is 1.2. It's not very deep, but for this city it's very deep. Present low potential to improve air quality. So there's nothing, very little we could do in this city in LC set 2 to improve air quality. It's too late. So the lesson I think is we are creating a problem and trying to solve it. That's what we are doing. Right? We have created this problem of lot of traffic, and then we are asking NBS to solve this. In the very first year of my architecture studies, the man said to me, creating a problem and trying to solve it is not going to give you any mark. This is what we are doing. We have the only thing to do here is to reduce the traffic. It's unfair to ask green infrastructure to solve the problem that we have created. We saw that it's 16,000 vehicles in this tiny place. That box is 200 by 200. It's really heavy vehicle, and it's impossible in that city to cut traffic at all. So there is very little you can do by NBS. That's the message. But the areas with low aspect ratio and with good exposition to wind flow perhaps can be improved. It's also very high in traffic, 8,000 vehicles per day, but that perhaps is possible in that city. So the take home, I suppose, is there is limited improvement possible by NBS in this city. The best thing to do is to stop the traffic. Thank you very much.
Thank you very much, Professor Manuel. Do we have questions?
Thanks a lot. Thanks for the presentation. I think planting trees or using grass to reduce temperature or humidify the air is a good approach for local environment. And when we talk about air quality, we can't talk only simply about next street or down the same street. We need to look at downwind, how it's going to affect.
Yeah.
If we put grass, we need to mow it at least once or twice per month. Okay, that's at least. And if you plant trees, you need always to wash the leaves. Otherwise, it will be poisoned by the dust or particles from motor vehicles. So, what's, in your opinion, the mitigation approach for planting trees or greening to be successful in the future? Otherwise, we solve a problem here and create downwind.
Yeah, I agree. And as I said, the green infrastructure is, should I have the map mic here? So, green infrastructure is it's not a panacea for everything. It could do something else. But in terms of traffic related air pollution, this city also uses a lot of very dirty fuel to heat. So, it's the residential air pollution is also quite significant. And then you have the 16,000 vehicles. So it's unfair to ask the trees to solve this problem. We need to solve it at the source. That is, I agree that trees are not the solution here. Yeah.
Thank you, Professor, for your insightful presentation. I'll just add to what introduced person said. That we know trees are a source of VOC. So, how do you think, when we address canyon ratios like this, we could look into mitigation?
Well, I didn't present this. We also did something in Glasgow where there is the move to make the entire city center avenues. They're planting trees. Basically, we have a lot of traffic-related air pollution problem. When we were a member state, we used to be fined every single year because it exceeds the EU limits. So they are now converting all the streets into avenues, basically taking off one lane of traffic and planting trees. This is seen as a panacea for everything. So instead of 4 lanes, now you have 3 lanes, one going this way and 2 coming that way. So this, whether the trees actually will survive, whether it would improve traffic, I don't know. It will certainly improve. We did some work. It will improve heat island for sure. Our problem, our 2050 climate would be this current London climate, and in London people do die of heat. So that's a good thing from that point of view. But whether it will actually, this is not done for heat island. It's done to improve air quality. Whether it will improve air quality, I don't know.
Right, thank you. I think the question was about the addition of volatile organic compounds. But, I mean, trees are good. I mean, that's a panacea. But have you seen any studies where the volatiles from the trees plus the NOx from the traffic in a street canyon, have there been any measurements of whether the ozone goes up or down? I mean, I think that'd be a really interesting study.
Yeah. No, I don't. I'm not aware of this. The interactions between the two.
So, okay, we have another few minutes, it seems, because in our program we now have 15 minutes time. So,